Precalculus, Chapter 2B, Day 1 notes. We're going to be looking at power functions now. Well, power function is a function that's in the form f of x equals a times x to the power of n. Okay? Well, it says a can't be 0, obviously, because 0 times x to the power of n is just going to be y equals 0. That's just going to be the x-axis, horizontal line. But it says, but a is a constant and n is a real number. Okay? So we've already looked at x to the first, which is linear, x squared, which is quadratic, x cubed, which is cubic. Okay? And we've seen maybe a little bit of x to the fourth, which is quartic. But now x can be raised to any power. So we're looking at any power functions. So let's take a look at this here real quick, very quickly. So if a is a positive number and n is a positive number, then here's an example, 2x squared. Okay, so 2x squared, you know what that looks like. Negative, okay, if a is negative and n is positive, then we could be looking at something like negative 2x squared, which looks like this. And now, because real numbers include all integers, so negatives as well, okay, you could have an example like these next two. So let's wait here just for a minute and let's graph some of these power functions and then come back and see if we can generalize what those will look like. So let's first look at this right here. We have a is -1/2 and b is -4. Excuse me, and n is -4. Okay, so if you just go in and graph this, okay, just go to Desmos and graph it, we'll see something that looks like this. Let's go to Desmos and graph this, shall we? Right, so if you look at your table, okay, here's a little piece of a table here that we have. The table shows that when x is 0, the function is undefined. Okay, your f of x, your y. So that's why you can see that the y-axis, which is where x is 0, is not touched by this function. And then you see a couple more points, -1, -0.5, +1, -0.5. And then if you go a little bit further, okay, it's getting a little bit closer to the x-axis. Okay, so at 2 you have -0.03125 for your function value. Same thing with -2. Right? So let's go back to our paper. Okay, and now let's plot those points that we had. We had what was it, 1 and -0.5. So we had the point 1, -0.5. That was 1 point. So 1 -0.5 is here. We also had -1, -0.5. So we were there. Then we had 0 was an error. Okay. And then we saw that as we get closer to 0, functions diving down. And as we get further away from 0, function is leveling off. It's getting closer and closer to the x-axis. Okay, so let's answer the questions over here. The domain of this function. Okay, well, if you remember that x to the -4th is the same as 1 over x to the 4th, hopefully you can remember unit 1 and say, well, x to the 4th is in the denominator, so x to the 4th can't be 0, which means that x can't be 0. That should make sense of the fact that your function seems to get really close to 0, but has to say, no, I can't be 0. I'm going to hop over it, start at -infinity, and come right back up. Okay? So my domain is all reals except for 0. Now, we definitely want to be doing interval notation by this point. So -infinity to 0 doesn't include it. 0 to infinity. Okay. What is the range? Range, how far down does it go? It goes down to negative infinity. Always go low to high, left to right. Okay. How high does it go? Well, as you can see, it kind of levels off really, really close. It's getting closer and closer to 0, but it never quite gets there. So negative infinity to 0. And then it never hops over, it never comes above the x-axis, okay, ever. X and y intercepts. Well, we said that it never touches the y-axis because x is never 0. So there is no x-intercept. And we said it never has y equals 0 either. So there are none. So we can say empty set for none of them, or we can just write there are none. There aren't any x-intercepts. There are no y-intercepts. Continuity. Once we start drawing this function left to right, can we keep going without picking our pencil up off the paper? Well, no, because there's a break here in the continuity. Okay? At 0, there's a split in your intervals. So now you have 2 different intervals. There is no continuity, okay, in your function. Symmetry. Well, we've studied 3 types of symmetry: x-axis, y-axis, and rotationally around the origin. So if you look at this, I think you can see that if you fold the y-axis over, that those 2 halves fold over onto each other. So I believe there is a mirror image reflection symmetry, and it's over the y-axis. And yes, because 4 is a even number, okay? It lends itself to being an even function and to have the characteristic of an even function, which is that it is symmetric to the y-axis. Okay. Decreasing. Where is this function decreasing? Well, remember, it's always left to right when it's decreasing. So I would say this entire interval here. So it starts at negative infinity, and it's getting really close to x equals 0, but it doesn't quite hit it, okay? So the interval where it's decreasing is from negative infinity to 0, but it doesn't include 0, so parentheses. Where is it increasing? Well, starting down and going up. It starts down, it's going up really, really quickly, and then it tapers off. It's still rising, but it's rising very, very slowly, okay? So it's increasing from 0 to infinity, all right? Now the end behavior. This one's just a little bit different than what we've had for our end behavior limits in 2A, right? Our end behavior here, as x goes toward infinity, what is the limit of y? Well, as x goes towards infinity, as you're going to the right, it's not going up and it's not going down as far as towards infinity or negative infinity. It's leveling off so that it's like it's getting really, really close to the x-axis, but like the x-axis is an electric fence and it won't quite touch it. It's approaching it, but it's not going to get there. So the limit for f of x is 0 as x goes towards infinity. Now, as x goes to negative infinity, which means we're going to the left, as we go to the left, once again, it's getting really close to f of x equaling 0, okay? Or y equaling 0 at the x-axis. But it doesn't quite get there. But that's where it's headed. So that's its limit. Okay? So it looks like as we go towards infinity and negative infinity, this function just wants to go to 0. It just won't quite get there. Okay? But that's what the limit is. All righty. All right. So let's go down to the next question. Okay. Graphs of radical functions. Well, graphs of radical function, very, very similar to graphs of these power functions, because powers and radicals have a pretty distinct relationship. All right, you learned it a little bit in algebra 2, okay? And that relationship is that when you have, let's say we had x to the power of 2/3, that's the same as saying x to the power of 2, but you're going to take the third root, or the cube root, okay? So if you have a power that's a fraction, okay, in fractional form, it's actually raising it to a power and then taking the root of the denominator in that exponent, okay? So radical functions, power functions definitely are related. Before we go straight to the radical functions, let's go back up here where we said we would return. Okay, now we looked at a being negative and n being negative. Okay, so if a is negative and n is negative, then we get something that looks like this. What if a is positive and n is negative? Well, just means that we weren't reflected over the x-axis. So you would have something that looks like this. Okay, now let's go down to your radical functions. Okay, so we have x being the radicand, which is a term that we've used earlier in the year, right? And then n is the index. Okay, so if the index is even, like for example, a square root, if we had the square root of 5, you don't write the square, but it is, there's invisible math again, okay? There's a 2 there that you just don't write if it's the square root. So if it's the second root, for example, okay, that's the square root of 5. So if we're talking an even root, the square root, the 4th root, the 6th root, the 8th root, the 10th root, and so forth, then the domain, kind of like this little graph right here, okay, is going to be from 0 to infinity. Can we have the square root of 0? Absolutely, it's 0. So that's why we have the bracket with our 0, because it's equal to, okay? It's greater than or equal to 0. The range starts at 0 and it's going up. So once again, 0 to infinity. The x and y intercept, well, if we have the origin is both the x-intercept and the y-intercept. So you can just put a 0 there. You could put 0, 0 there if you want. Okay? But the x-intercept is 0, the y-intercept is 0, and that's the origin. Okay? Continuity. Is this thing continuous? Well, once I start to draw it from left to right, do I ever have to pick up my pencil? No, you don't. So because your pencil can go continuously, yes, this function does have continuity. Okay? What symmetry does it have? Well, if it had one of these, it would be symmetric to the y-axis. It doesn't. If it had one of these, it'd be symmetric to the x-axis, but it doesn't. And if it had one of these, it would be symmetric to the origin, but it doesn't. So there isn't any symmetry, okay, in this type of a graph. Okay? If the nth root of x has n being even, no symmetry. Okay? Where is this decreasing? Well, as long as n is a positive integer, it isn't. Okay? We are not decreasing. Okay? We're increasing out of the entire domain. Okay? So you're increasing from 0 to infinity. What is the limit of f of x? What is your limit of your function y as x approaches infinity? Well, as we go to the right, as x goes towards infinity, we're going up. We're going up very slowly, but we are going up and it's not bounded. So yes, the limit is infinity. Okay. Now, what about as x goes toward negative infinity? Well, as x goes towards negative infinity, there's no function. Our function stops at 0. So there is, put that back there, there is none. There is no limit. Okay, so we can do empty set. There is no limit as x approaches negative infinity because x doesn't approach negative infinity. All right. Now, if n is a positive integer and odd, okay, if it is the cube root, the 5th root, the 7th root, okay, then you might have a graph looking like this little baby right here. All right. So what is the domain? Well, it looks like it goes all the way to the left, all the way to the right, and it doesn't have any breaks in between, so it has all real numbers for its domain. How about range? It goes down, it goes up, and there's no break in between here. All the y coordinates are accounted for. So once again, all real numbers for the y. The x and y intercepts, well, the only time that it touches the x-axis is at 0, and that happens to be the y-intercept as well. So 0, 0 is your x-intercept, 0, 0 is your y-intercept. Is there continuity? Well, once you start drawing, do you ever have to pick your pencil up? You don't. So there is continuity, right? That would be yes. Is there symmetry? Well, it's not symmetric to the y-axis because this would have to be over here. It's not symmetric to the x-axis because that would have to go over here. But yeah, this is symmetric to the origin, like an odd function. Okay? All odd functions were symmetric to the origin. We learned that back in Unit 1. So we are symmetric to the origin. Right? Where is this decreasing? From left to right, we're going up, 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 up really fast. Now still up, but just not as fast. This is never decreasing. Right? Never decreasing. We could put the x back there if we want. Like we did over here. Don't want to get too inconsistent. We're always increasing from negative infinity to infinity. So we're going increasing over all the real numbers. Okay. The limits for the end behavior as x goes toward infinity. Well, y is going up. It's not going up fast, but again, it's going up. So it's going to infinity. It's not leveling off to the point where it's going to stop. And if you put one of these in your grapher and then you look at your table, put under your x, put like a million or a billion or a trillion, or just keep going, and you'll see that your y, your f of x, keeps going up, right? It does not level off toward a number like we saw earlier with this function here, leveling off, getting really close to 0, but never jumping over. These ones just keep going up and up and up. Okay, so likewise, as we go to the left, if it's an odd index, then we are going to go to negative infinity with our x, and the y is going down, 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 down. Okay, there we go. Let's continue on. Okay. So f of x equals 2x to the 3/4 power. And we mentioned that the exponents have a direct correlation to radicals. Okay? If I want to rewrite 2 times x to the 3/4, I can rewrite it like this. So this particular question, kind of ties into the very first group of examples we looked at, right? And now it ties into the radicals as well, right? So 2 times x to the 3/4, or 2 times the 4th root of x cubed. right? If we're looking at this, why don't we graph this? Let's go to Desmos and graph this. And you can see, this function's pretty much the same as your square root of x, or your x to the 1/2 that we had back at the beginning of the notes. Okay, as far as it starts at 0, 0, and then it starts rising to the right. Take a look at the table here. You notice that 0, 0 is a point, and if you go to the left of 0, 0, it's undefined. There is no function when x is negative. Okay. Beyond that, 1, 2, and 2, 3.36, etc. Okay, are a couple more points that they have given you here, and they pop up there. Right. So let's go ahead and graph it on our paper. Let's just plot a couple of points from here. We remember the shape of it, right? And now let's answer the questions here, asking for the domain. The domain, again, it starts at 0 and includes 0, and it goes to infinity. Okay, you can make your x as large as you want, starting at 0. Okay? It goes to the right. Also goes up infinitely, so 0 to infinity for your range. How low does it go? 0. How far up does it go? Infinitely. Okay? The x and y intercepts, well, again, it's at the origin, so x-intercept is 0, y-intercept is 0. Does it have continuity? Sure. Once I start drawing, I don't have to pick my pencil up to finish. Okay? So yes, it does have continuity. Is it symmetric to anything? Nope. There is no x symmetry, y-axis symmetry, or origin symmetry. When is it decreasing? Well, this thing is never going down. Okay? It's always increasing, so never decreasing. And when is it increasing? It's always increasing, 0 to infinity. Okay? What is the end behavior? As x goes towards infinity to the right, y is getting higher and higher, so it's going to infinity. As x goes to negative infinity, the function's not there. Okay, remember, it was an error. Okay? So because it's an error, there is no limit. Okay? Your y is not going anywhere because it's not there. Okay? There is no function. Okay? Now let's do a little power regression. You're going to take your either your Desmos or your TI-84, and you're going to input this data. Okay, so have all of your L's, which is going to be the body length in centimeters of African golden cats. Okay? All the L's will put in L1, and all of the M's, which is your mass of your African golden cats in kilograms, we're going to put that in L2. Okay, so go ahead and input that. I'll input it also, and we'll meet here in a second. Hit pause button, and I'll be back with you. Okay, so I've inputted all of the x and y coordinate, or the L and M coordinates here into this table. Okay, and I'm going to have Desmos graph it for me. Okay, so I have, my window is such that I can see all of the x's from 72 to 90, and I can see all of the y values that are between 11 and 18. Okay? So now that I've got the scatter plot made here for my data, now it says determine a power function. A power function. So remember, a power function, which is what we looked at the very beginning. Okay? Power function is in the form of y equals a times x to the n. Okay, so let's look at putting this into Desmos and seeing exactly how we're going to get our regression from Desmos. Okay, hopefully you know how to do it with your TI-84. You're just going to go stat calc. Now you go down to power reg, PWR reg, and then you do the exact same thing that you did in the previous chapter with 2A. Okay? It's just a different type of a regression, right? So what we're going to tell Desmos to do is we're going to say, because we have, these are called Y1s and X1s up here. You see right there, that's Y1 and this is X1. Okay, so we're going to go Y1, and it's going to want the little tilde here, which is there. Okay, Y1 is going to be, what do we say, A times X, in this case X1, because it's a very specific X that we want, but it's going to be raised to the power of N. Now you can use B or anything else, but I mean, since we had an N already, I'm going to put an N there, right? And let's look at this here. So there's your power regression curve that goes through your data, okay? If you notice here, the R squared is only 0.79. It's not real close to 1, so it's not a great fit, but they did ask us for a power regression. So this is our power regression curve. And they did give you the A and the N, if you notice right there, underneath where it says parameters on the left, right? So we do know what A is, we know what N is. So let's copy that onto our notes, and then we can do this last question. Right, now, as much as I love the TI-84s, and the TI-84s, would be great to just go to the table. Okay, if we look at this next question and we say length of 77, well, the length was the independent variable, is like our X coordinates usually. Okay, so if this was my X or X1, we want to know what is the mass of the African golden cat according to this regression equation. What is the mass of that cat if the length is 77 centimeters? Good question, okay? Well, as I said, you could just go to your table if this were a TI-84, but the table doesn't help you much in Desmos. But Desmos is not a Y equals grapher, okay? It's just a grapher, right? So the nice thing you can do with Desmos is if the X coordinate, in this case, because L was the X coordinate, L was the independent variable, if we want to graph where is the L equal to 77 centimeters, we can just type in the vertical line equation, X equals 77. There it is. So when X is 77, this tells me that my regression equation says that the 77 centimeter African golden cat should have a mass of approximately 14.131 kilograms. Okay, so that should give us approximately, is it 14.131 kilograms. Okay, so we've gone back to the TI and we've, or Desmos, and we've done a little scatter plotting. Okay, now last thing we want to do is we want to solve some equations. So those of you that like the algebra, this could be the fun time here for you, right? So this is the steps, and also we've done one out for you, and then we will do a couple of questions with you or for you. Okay, so the goal of solving the radical equations, okay, first thing you need to do, just like when we solved absolute value equations, you wanted to isolate the absolute value brackets, the sticks. We're going to do the same thing here. If there's a radical, we want to isolate the radical. Okay? So first thing we're going to do is get the radical by itself. For example, for this question right here, The radical has this -1. We don't want the -1. We want the radical isolated. So we would go +1 to both sides, okay? And when we did that, you would get the radical all by itself equals to 6. So then it says, raise each side of the equation to the power that is equal to the index. Well, this is the second root, the square root. So that means they just want you to square both sides. If it was the cube root, we would cube both sides. If it was the fifth root, we would raise both sides to the fifth power. Okay, so when the square root is squared, it vanishes, okay? Leaving us with y -2. And then we have equals 36. Now, you might be saying this, so I'm just going to throw this out there. You know, hey, we're squaring both sides, so we should have a +-. Now, when you square root both sides, you should +- your answer. But when we're squaring both sides, that's not a +-. Completely different, okay? Even though I get it, I understand the logic there, okay? But there's no connection. So now you just add 2 at the end, okay? And you're solving. You got y = 38. The last step, and I'm telling you, this one's important because there are going to be some extraneous answers. And there's extra in the word extraneous. There are going to be some extra answers that don't work. So make sure you check every one of your answers. So y = 38. Let's try it. The square root of 38 minus 2 is the square root of 36, which is 6. Minus 1 equals 5. This one does work. Okay. Let's go and try example 1. Okay. Example 1 has a square root on one side. There's a +12, so the first thing we need to do is subtract 12 from both sides of your equation. Cancels nicely. Now I've got my radical isolated, and it's equal to x - 2. Right? So now that my radical is isolated, my index is 2, even though I don't have it written, invisible math. So I'm going to square both sides of my equation. Okay. So if I square the square root, this side's always easy. I just take the square root off. X - 2, all squared. Common math mistake is to say x squared - 4 or x squared + 4. Because remember, x - 2 squared means x - 2 times itself. You need to FOIL it out, and you will get x squared -2x - 2x, which is -4x. And then -2 times -2 is +4. Okay, now it should look like something we've done before. Okay, we've got an x squared. Okay. If I could get equals 0 on one side, then I can either factor it or I could use quadratic. So we need to subtract 3x and add 2. I'm going to do both of those steps at once. Your pre-calc, you can handle it. Okay, so we got 0 equals x squared has not been touched. -4x - 3x is -7x. +4 + 2 is +6. Okay? Now, lo and behold, this one looks like it's going to be factorable. So I'm not going to worry about quadratic. If you wanted to quadratic it, be my guest. It's not going to hurt. It's all good. Okay, product sum. Product is going to be 6, positive. Sum is going to be 7, negative. So that tells me it's going to be -6 times -1. Now, there's no coefficient that's bigger than 1 here, so I don't have to do the grouping method. This is just a straight product sum. So I got 0 equal to x - 6 times x - 1. And if I split this, I find out that x - 6 could equal 0 and x - 1 could equal 0, which gives me solutions of x = 6 and x = 1. Okay. Try them. X = 6. Let's go right back to the beginning here. Let's put our 6 in for x. 3 times 6 is 18, minus 2 is 16. Square root of 16 is 4. 4 plus 12 is 16. Okay. On this side, 6 plus 10 is 16. X equals 6 gives me a true statement. X equals 6 is a good solution. Okay, let's see if we are as fortunate with our good friend x equals 1. So for x equals 1, 3 times 1 is 3. 3 minus 2 is 1. The square root of 1 is 1. So we get 1 plus 12, which is 13, equals, put the 1 on this side, 1 plus 10 is 11. 13 equals 11. No, it doesn't. X equals 1 is an extraneous solution. Means that we came up with it when we did our calculations, but it's an extra. Okay? It doesn't work. It's not a real solution. Because if I graphed this right here, okay, the solution would give you 6, but there would be no solution when x is 1. Okay. All right, let's go over to question 2 on this side. All right, again, we have a radical. This time it's a cube root. We still have to isolate it first. Okay, so we go back to isolate the radical. Okay, so I'm going to have to subtract 4 first. Careful. If you just said, I want to divide by 2, that's okay, you could, but you would have had to have divided this by 2, and this by 2, and this by 2. Okay? People make mistakes with that, so I would advise you against it, but there's nothing wrong with it. You would have the cube root plus 2 equals 0. Okay? So if you do that, it's okay. You just have to make sure you do it correctly. Okay? All right, but let's just do this. So plus 4 minus 4 cancels. I got 2 times the root, cube root of x minus 5. Got to cancel that too. So let's divide by 2. So I've got the cube root of x minus 5 is equal to negative 4 divided by 2 is negative 2. Okay, so the last thing we got to do, we got to cube it because it's a cube root. Okay, we got to do that and solve it. Okay, cube root and the cube, they cancel. Negative 2 times negative 2 times negative 2 is negative 8. Plus 5. I get x equals negative 3. Okay, don't forget, check your answer. Okay, so x equals negative 3. Let's try it. So negative 3 minus 5 is negative 8. The cube root of negative 8 is negative 2. So 2 times negative 2 is negative 4. Negative 4 plus 4 on one side, 0 on the other side. This one works. Okay. So x equals negative 3 is a good answer. It's not extraneous. Okay. And you may say, well, you only got one answer. Can't be extraneous. You can. There can be no solutions. Just like when we had, you know, some graphs that never touched the x-axis. There were times when there were no real zeros. So there may be times that you have an answer where there is no real solution. So just beware. Okay, so now, look at this. What? You can never have too much of a good thing. This is really radical because there's 2 radicals. Okay? Sometimes squaring both sides of an equation still results in a radical. But often there is one less than before. So all you would do is you would do it twice. Step 1, isolate one of your radicals. So for this question here, both radicals are on the same side of the equal sign. We can't have that, okay? I want to isolate a radical and then cancel it. And then if there's one more radical, I'm gonna isolate that radical and cancel it. So let's do that. Let's take this minus one. Let's get it out of here. So let's add root x plus 3 to both sides. That's a 3. Okay, that cancels. So I got root x plus 15 equals. Now what is 2 plus the square root of x plus 3? Well, 2 and root of something are not like terms, so it remains, we can do that, 2 plus root x plus 3. Brilliant, right? Thanks. Okay, so now I've isolated this radical. Step 2, I'm going to raise it to the power of the index. So I'm going to square it. Means I'm going to have to square this whole side over here. Don't groan too much. Okay, this side's always easy. Think with happiness and joy about the fact that the square root and the square are just going to magically vanish because they're inverse operations of each other. You get x plus 15. This other side is a binomial, and we're squaring it. So we have to multiply it by itself. So I'm going to do it in some workspace over here. Let's put some workspace right here. So 2 plus this square root times itself. Okay, again, don't whine or moan or anything. Let's just FOIL it. Okay, it's just foiling. It's 2 binomials, no big deal. Okay, first, 2 times 2 is 4. Outer, 2 root of x plus 3. Inner, it's another 2 root x plus 3. And then last, root x plus 3 times root x plus 3 is like squaring the square root, which means square root's gone. So I've just got plus x plus 3. Well, that's not bad. Really, seriously, come on now. So we've got, what do we got? We got a 4, and we got a plus 3, so we got 7. And let's see, we got a plus x. And now we've got plus 2 root x plus 3 plus 2 root x plus 3. So what do you get when you take 2 of these roots and add 2 more of these roots? You get 4 of those roots. 4 root x plus 3. Okay. There's no like terms over here. But look at this. I'm going to isolate my root x plus 3. So I got to cancel this 7, and I got to cancel this x. Well, wasn't that nice? The x's are going to cancel like good little x's should. All right? So the x's cancel. 15 minus 7 is 8. Cancel, cancel. That's 4 root x plus 3. Now it's easy. Okay, see it? I told you, don't worry about this. This is going to work out just fine. Okay, we haven't isolated our radical. Okay, we have to divide by 4. 2 equals root x plus 3. We've isolated the radical. It's a square root. Second index. Square, square. 2 squared is 4. Square root in the squares, bye-bye. X plus 3 equals 4. Now tell me that's not nice. Actually, don't tell me. Okay, 4 minus 3 is 1 equals x. So we got us x equals 1. Well, that's pretty nice, I think. Let's just check it before we go very far. Okay, erase this a little bit. So again, we're checking x equals 1. So 1 plus 15 is 16. You take the square root of 16 and you get 4. 4 minus 1 plus 3 is 4. The square root of 4 is 2. Then on this side, it says equals 2. 4 minus 2 equals 2. Check. X equals 1 is a good answer. Okay, so we're going to keep it. Okay, let's do the same thing over here. Now look. One of these radicals is already isolated. Isn't that nice? Let's be thankful for that. And let's square it. Okay. So squared here. Squared here. I know. It's okay. It's okay. Okay, let's square the left side. You're going to get x plus 7. We're going to do a little workspace here on the right side. Okay, 3 plus root of 2 minus x times itself because we squared it. 3 plus root times 3 plus root. Okay, let's first it. Let's outer it. Let's inner it. Let's last it. Root 2 minus x plus, times root 2 minus x. The roots cancel. And you just get 2 minus x. Easy peasy, right? So let's combine like terms. We got a 9 here, and we got a plus 2, so that's 11. We've got a minus x here. Yeah, this one's not going to cancel. That's okay. And we got a plus 3 root, plus 3 root. So that's going to be plus 6 root 2 minus x. Okay, so we went from 2 roots to 1 root. Now we have to isolate the 1 root. So we got to isolate this thing. Let's subtract 11. And let's add x. Okay. So here we go. X plus x is 2x. Plus 7 minus 11 is minus 4. Okay. And we got the 11's canceling and the x's canceling. And we've got that equal to 6 times the root of 2 minus x. Okay. Next thing we need to do, I can anticipate need a little bit of room down here. Next thing we're going to need to do is isolate the radical fully by dividing by 6. Well, we got 2 terms here. Sure, let's do it like this. Okay, I could have just put the whole 2x minus 4 over 6. Okay, that actually, yeah, let's do that. I think you'll like that a little bit better. Okay, let's do that. Okay, here we go. So we've got 2x minus 4 all over 6 equals root 2 minus x. Guess what we're going to do? That's right. We're going to square it. I mean, word to the wise, even though I would keep this as 1 fraction, I would probably still reduce it right about here. Okay? So you get, divide everything by 2, you would get x minus 2 over 3. Okay? You don't have to do that. We're going to end up dividing it at the end if you don't. So if you're not worried about it, I'm not worried about it. So let's square both sides. So here we go. On this side, we get 2 minus x. Easy peasy. On this side, we get a fraction. So 2x minus 4 over 6 times 2x minus 4 over 6. Okay, the denominator is 6 times 6, which is 36. That's easy. The numerator is 2x minus 4 times 2x minus 4. And we've got to FOIL this. So 2x times 2x is 4x squared. Hey, dude.
Mom's phone
Yep.
is out of charge.
Sure. There you go. Okay, bud. Okay. 2x times minus 4 is minus 8x. Minus 4 times 2x is another minus 8x. And minus 4 times minus 4 is plus 16. Okay? So we're going to put that in this numerator over here. Let's combine like terms. So we're going to have 4x squared minus 8x minus 8. So minus 16x plus 16. Woo-wee. Well, this one's a little bit more fun than the other one was. Okay, so check out what we got to do. We have a fraction here. Don't want that. I want to clear that fraction, so I'm going to multiply both sides by 36. Some people may think of that as cross-multiplying, doing the same thing. So either way, you're going to multiply 36 times 2 minus x. On one side, it's just going to be 4x squared minus 16x plus 16. On the other side, you're going to take 36 and multiply it by 2 minus x. Okay, so we got to distribute that. See what we get. We got 4x squared minus 16x plus 16 equals 36 times 2 is 72 minus 36x. Okay, now there's no fractions, there's no parentheses. That's awesome. Now we just got to get 0 on one side and then see if we're either going to factor it or we're going to quadratic it. So here we go. Subtract 72, add 36x, okay, 4x squared minus 16x plus 36x is going to be plus 20x. Plus 16 minus 72 is minus 56. I do believe. These cancel, giving you 0. So you got 4x squared plus 20x minus 56. So you got to figure out, do you just want to put it in a quadratic or do you want to try to factor it? Well, if you're going to factor it, you got to always divide by the GCF first. And there is a GCF. Okay, remember I had said back here, I probably would have reduced it. Okay, you got to have to divide sometime. So let's divide right now. The GCF for these three terms is 4. So I'm going to divide all of these by 4, and I'm going to get x squared plus 5x minus 14 equals 0. Now this is just 4. There's no x out there. So if I divide both sides by 4, the 4 is going to vanish. Okay. Now I'm going to say that a little slower, and I'm going to show that here instead of just glossing over it because it's important conceptually. 4 times x squared plus 5x minus 14 equals 0. Okay, so before when we took a GCF out, we kept it because it had x's and therefore it had zeros in there. Okay, we would say, well, this had an x in it, so x equals 0 or something like that. This is 4 times something. So I can just divide both sides by 4. This cancels. Yay. Okay, and 0 divided by 4, just 0. So I've got x squared plus 5x minus 14 equals 0. So remember, if you're going to factor, always look for the GCF. Okay, if you didn't think about that and you said, I don't know if it factors or not, you can always use quadratic. You can always use quadratic. So use the quadratic if you're in doubt. Okay, all right. So let's finish this. Is this factorable? Well, that's a 1 in front of my x squared, so we can just product sum this little baby here. The product is negative 14, the sum is positive 5. I think it's factorable. I really do. Okay. Minus 7 plus 2, or plus 7 minus 2. Yeah. Yeah, plus 7 minus 2. Plus 7 minus 2. The product is negative 14. The sum is positive 5. So let's do it. X plus 7, X minus 2. Okay. Cha-ching. So that means X plus 7, the factor, gives me the 0 of negative 7. And X minus 2, the factor, gives me 2, the 0. Okay, let's try them. Remember, try your answers, okay? Let's try X equals negative 7. Okay, let's put that right there. Negative 7, let's put it right there, negative 7. So negative 7 plus 7 is 0. So 0 equals 3 plus square root of 2 minus negative 7. Well, 2 minus negative is 2 plus 7, so that's 9. So 3 plus the square root of 9 is 3. Uh-oh. 0 does not equal 3 plus 3. X equals negative 7 is an extraneous solution. How about 2? Don't take for granted that it is. Okay? Don't guess. So let's put 2 here and here. Okay. All right. 2 plus 7. Take the square root of 2 plus 7. Okay, so the square root of 9 is 3. Equals 3 plus 2 minus 2, and you take the square root of it. Well, that's 0. Hey, 3 equals 3, yes. So my answer is X equals 2. Day 1, in the books. Hope you enjoyed it. Those of you that like the algebra, hope you loved it, because I kind of love it a little bit. All right, hey, see ya.